Okay, so the 21 minutes past 10, I call this session what would you like. I'll call it the what would you like session. So let's see, what would people like? Give me the grade, give me the topic. If I feel like it, I'll do it, but if I don't, I won't. Okay, nobody wants anything. K, hello K. Is it K? Katleho, what grade are you in? Mini, hello, what grade are you in? Who else has been liking the live? Neo, what grade? Nice send, what grade? What would you like? Nope. Optimization, grade 12. No, not even there. Not even there. Not in my head, not in my thoughts, not anywhere. I'm sorry about that. Askies. Boita Obo. Yeah, you just even joined in actually. Oh, I see. K is in grade 10. Katleho is in grade 10. Okay. What are you guys up to in grade 10? KT? Anything in particular that you would like to actually look at? I see there's 2 grade 10s that are here, so I'll give those dibs, that preference to the grade 10s. Seems like they're predominant here. My brother, you good? Did I reply? Did you? I doubt it. I doubt you replied. I think I had asked you about how many sessions. Didn't think you replied there. Tebo Katleho is saying a trigonometry for grade 10. Trigonometry grade 10. Any secondas there? Trigonometry. How many times do I think this is good for a month? That is entirely dependent on the man, on the person. Besides, because your package actually for the amount that you'll be paying, it will also include sort of access to being able to contact, and you know, if you're doing work, you can always ask questions and so forth. So I need to hear it from you, because you're gonna see the demand of the work that you're covering in the week, and maybe you may need just sessions for clarity, sessions maybe specifically to cover something. So you let me know. I need to know from you. So what, maybe twice a week? 4 times a week. I think honestly twice a week with the inclusion of being able to contact me, I think would be good. You know, I'll give you my contact detail as well, so then you can be able to have the liberty of being in touch. All right. Yeah, so what is the preferred topic of choice? Thing is, we are also trying to transition into term 2. And I do know that, for instance, the grade 10, some of you may have not covered the trigonometry topic to your satisfaction. And maybe that's why, for instance, Katlejo is saying trigonometry. Okay. I just need a person to second. Are there any seconders of trigonometry? Okay. Because if there are, then I can do it. But if not, maybe we can pursue a grade 10 topic that is basically going to be covered in term 2. Like, for instance, Euclidean Geometry. But if there are seconders of trigonometry, then I'll do trigonometry. Anyone who is seconding trigonometry for grade 10? Okay, maybe Katlejo, just let me know in the comment section what is it specifically that is that you feel like you are not comfortable with when it comes to trigonometry. Which part, what aspect of trigonometry is a bane? Alright, so let me just... Okay, let's do some grade 10 trig here then. I think it's safe to say. Katlejo, are you in the position to speak? Are you in the position to speak? Are you able to speak, or you can't? Trigonometry. So grade 10, hey? Okay, so with grade 10 trigonometry, it's quite, I think, basic. There's this very important mnemonic which we call SOHCAHTOA, and we know most in grade 10 trigonometry is specifically applied for right angle triangles. So if we have triangle ABC, and let's look at these triangles respectively. Let's just say this is theta here, and let's say we have another triangle here, and let's say this angle is beta, so let's say it's DEF. Okay, and then it's a right angle triangle. Remember, trigonometry means trig itself, onometry. Okay, this has to do with the fact that we are dealing with triangle. Okay, and then metry means we are having to deal with measurements. Okay, so it's the measurement of angles and sides, the measurement of angles and sides applicable specifically to your rats. right-angled triangle, RAT, okay, right-angled triangle. So if we look at the definition, Johnny, when am I going to host grade 11 live? Okay, I don't have a time specifically when I'm going to be hosting grade 11 live. Just today, like I said, I just came on to not really host a specific grade live. I just wanted to check what issues and problems do people have. So maybe, Johnny, if you have a specific problem in grade 11, you can just let me know in the comment section, and then I'll be maybe attending to that maybe a little bit later. I don't know if people are actually intending to sleep anytime soon. Maybe, Johnny, you can say, I'm intending to sleep at this time, or whatever the case may be, but we may see how we can attend to that. Okay, sorry guys, back to TikTok. Okay, I'm sorry guys, sorry for that. So sine, let's say sine. Now obviously sine is a trigonometric definition. All right, sine, and then we say sine of a specific angle. All right, so let's say sine of theta. Now the definition for sine is it's always your opposite side over, I'm sorry about that, your hypotenuse side. So opposite side, you look at theta, there is theta, you ask where is your opposite side. Okay, your opposite side, what is the side opposite to theta? It is your side AB. So we would say AB, because the definition of sine is opposite divided or over the hypotenuse. Then your hypotenuse side, the side that is the hypotenuse is always the side opposite the right angle triangle, your 90 degrees. So that is AC. So sine of theta, according to this right angle triangle, is AB, because AB is your opposite side, the side opposite the given angle that is mentioned, which is theta, and then the hypotenuse side, which is the side opposite the 90 degree angle. The side opposite the 90 degree angle is always called the hypotenuse. Okay, then let's move on to the next definition. Cos. Cos is A, meaning adjacent, over hypotenuse. Okay, the H stands for hypotenuse, the A stands for adjacent. Okay, adjacent means if we're looking at this angle theta, it is the side next to the given angle, the side next to the given angle. That's BC, not AC, because we know AC is the hypotenuse side. So it's not the hypotenuse, but it is the side BC. It is called the adjacent side. So we say BC over AC, because the definition of cos is adjacent over hypotenuse. Then tan of theta would be, we look at the angle, the definition for tan is O means opposite, A means adjacent. So it's your opposite side over the adjacent side. So we go to theta and we ask, where is the opposite side? It is AB, because AB is directly opposite the angle theta, as you can see. Then where is your adjacent side? Your adjacent side is BC, the side that is next to the angle. It's BC, right? So that's AB over BC. Okay, so that is the definition, all right, that we know our trig definitions should go whenever we have the angle theta. Now let's look at when we are given another right angle triangle, but this time around we are looking at the angle from the top. Okay, so once again, this is the angle, so that means we are going to be looking at sine of beta. The definition still of sine is opposite over hypotenuse. So the opposite side, what is opposite this angle beta? It is EF. So the side that is directly opposite is EF. So we say EF over the hypotenuse side, opposite over hypotenuse. The hypotenuse is DF. Okay. We ask what is cos of beta. So cos is still by definition adjacent over hypotenuse. So the adjacent side, okay, is DE over DF. Okay. Then last but not least, we look at tan. Tan of what? Of beta. So tan of beta, the definition of tan is opposite over adjacent. The opposite side to this angle is EF, and then the adjacent side is DE. Okay, so this is us just using the definitions to be able to find the different trigonometric ratios, and that's very important. So we must always know that the trig ratio, or the definition, we must know what it says. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Then SOHCAHTOA helps us with that. The angle given helps us to be able to identify the opposite and the hypotenuse. I mean the opposite and the adjacent side. Whatever angle is given will help us identify this is the opposite, this is the hypotenuse, this is the adjacent according to theta. But according to beta, this is the opposite, this is the adjacent, and then obviously the hypotenuse is always opposite the 90-degree angle. Okay, so that is the basics: sine, cos, and tan. And then you tend to do problems around these trig ratios. Okay, and I mean, really guys, there's nothing much to that. Okay, so your most basic problems require you to just use a given triangle and then be able to express the sides of that triangle in terms of the given trig ratio. Okay, so yeah, there shouldn't be much of a big deal. There shouldn't be much of a deal that is big. You see? Yeah, so let's get this guy here. Let's get him on here. Mr. Katlego. Mr. Katlego, are you here?
Yes.
Or is it Mrs. Katlego?
Katlego.
Not Mrs.
No.
Not Mr. Okay, so you're understanding these trig definitions, no problem.
Yeah, I understand that.
Okay, so what is the real pain for you in this trick, so that I don't spend time doing things that you are familiar with? You're like, I know this. I mean, don't waste my time. Do you have any particular questions that tend to really, or maybe you guys did trigonometry, must you finished it and all in school?
Yeah, I don't.
So what?
How
what
to
was-
calculate?
calculate
How
what?
to calculate when numbers are included?
When numbers are included. So when you have to find a side and an angle.
I think so. I haven't learned that. But
What
I
have you-
wrote a test about it.
Or you haven't learned that at school?
Yeah, but I wrote a test about it.
Okay, look, I'm gonna look at a few examples and questions here, and then I'm gonna check if you are good. Do you have your calculator with you?
Let me go and fetch it.
Amen. Okay, here we have it, guys. A is equal to 23,8, B is equal to 18,1. And usually these questions say round off your answer to one decimal place. Were you able to get it? Oh, it's still gone. Okay.
Huh?
Oh yeah, Katlego, please do let your parents know that you are in something like this so that they don't get freaked out and they're thinking, hey, what is Katlego doing, speaking to some stranger or something like that. Okay, so guys, here we have a question here. It says A is equal to 23,8 degrees, B is equal to 18,1 degrees, and then it says round off your answer to one decimal place. All we need to do now is we need to determine the value of. Okay, determine or determine, some people say, the value of the following. Okay, the following: sine of A plus B, tan to B, cos squared 2A minus 10 degrees. So can you do these ones, Karlecho? No, I mean, no problem. Hello, Karlecho.
Determine the value.
Yeah. Of the following.
How do I do it?
If A is 23,8, B is equal to 18,1, and it says round off your answer to one decimal place. Okay. So we are told that A is 23,8. Okay.
Yes.
We're told that B is 18,1.
1.
Now we need to determine the value of sine of A plus B. So how do we do it? What is the value of A? 23,8.
24.
23,8. We are told it's 23,8.
23,8.
Yeah, and then B we are told is 18,1.
18,1.
Yeah, so it's these two angles. So all we do is we just substitute
A and B by
exactly
23,8
yes
and 18,1.
Yes. Yeah, all we do is we substitute, and then after that use our calculator. Right, take all of this sine, take your calculator, you put all of this inside the calculator. Tell me, what do you get? Because I want your answer rounded off to 1 decimal place. So you tell me, what do you get?
23.8 plus 18.1. I get 0.667.
0.667.
I shall count all the numbers or what?
Yeah, I wanted to initially have all those numbers so that we can then see how we round off together.
832.
Okay, 832.
5555.
Okay, 4 5s. Okay, then we are told we round off our answer to 1 decimal place.
1 decimal place.
So what would be the answer if I round off to 1 decimal place?
0.7.
Yeah, there we go. 0, of course we cut off things here because we want a 0.1 decimal place, but then we know that Mr. 6 says what to the 6 here? If the number is 5 and more, it says to the previous number, we must go up. So that's 0.7. Okay, not too painful, hey? Let's look at B. Now you're supposed to find tan of 2b. Okay, b is equal to 18.1. Can you work this one out for us, Katleho? Tan 2b. Now we need to find what tan 2b is.
Well, I must substitute b with 18.1.
Okay. How does that look like? Tan 2. What do we write when we substitute?
Into a bracket, the open bracket.
Yeah, thank you.
Then 18.1.
Ah, look at that. Yeah, you see the way you said that, into open bracket. You're a true mathematician, you. Okay, then when you substitute.
And I must punch my calculator.
Amen. Yes, please do.
This time 2. And yeah, I'm stuck right now.
You are stuck. How?
I don't know how can I put the 2 before the brackets.
You don't know how you can put the 2 before the bracket. Which calculator do you have? Do you have this one? Oh, okay. So there's my tan. Here's my tan.
Yes.
In essence, what does the bracket mean?
Multiplication.
Exactly. So we can say 2 times
2 times 18.1.
Exactly, and then we just close everything in there, you see. Do you get what I get?
Yes.
So can we round off that to 1 decimal place? What's the rounding off of the 1 decimal place?
0.70.
0,
70.
1 decimal place. Remember, 1 decimal.
Okay, 1 decimal.
Remember, it says round off your answers to 1 decimal place. We are still busy with these problems, and they are saying round off your answer to 1 decimal place, all of them.
73.
So it's going to be 0, What does 3 say to the 7?
I think it doesn't change. 0.7.
Exactly, it means we stay the same. All right, remember 1 decimal place. I'm just gonna write out all of this. 188936115. 1 decimal place, we cut off here. There should be 1 number after the comma, but then we look at this number. What does it say to the previous number? This number says we stay the same. Remember, if the number is 4 and below, then it says to this number we stay the same. So our answer is 0, 7. Yeah, you could swear we are cursed with 0, 7. Can you see? The next one. This one I have to see you. You need to lead me in this one. I'm going to take your guidance. What do I do here?
Take me back to the one, yeah. Okay, 23,8.
Yeah. So we're gonna substitute 23,8. Minus 10 degrees. Okay, are we together here? So we substitute 23,8 in the place of A. Now this is something for you to note, because this is very important. So we can actually then find out what 2 times 23,8 minus 10 is in the bracket, so that we know what that single value is. So we can go ahead in our calculator and just 2 times 23,8, 2 times 23,8 minus 10 . What are you getting there?
188 over 5.
Yeah, 188 over 5, which is what as a decimal?
Then in decimal, 37,6.
Okay, so that means we have that now inside the bracket. Now we need to evaluate that. Okay, and when we evaluate that, what do? We do the following. You see, whenever there is a exponent for our trig ratio, we can actually write the trigonometric ratio 37,6, meaning cos of 37,6. Then we take the exponent and we write it external to the entire thing. This is very important here. All right. So whenever you have an exponent for your trig ratio, okay, you, after having gotten what the angle is for the compound angle, which is 37,6, you can then take out the exponent. Take the exponent for the entire trig ratio, cos of 37,6, the whole thing squared. And now, I'm sure you can use your calculator. You make sure that cos 37,6, you square everything, and you should get the answer. Okay, and this is something I wanted to just point out for us, so that whenever we have an exponent, we must always remember that we write the exponent external to the trigonometric ratio. We evaluate the trig ratio and its angle, and then we square the entire thing. Okay. Are you feeling me? Are you feeling the energy of what I'm saying? Does it make sense? Or it's like I am lost, say now. Okay, if it was to the power 3, you take the exponent 3 outside. If it was to the power 5, we take the exponent to the power 5 outside. So you can go ahead now and say cos of what? Of 37,6. Then what you do is you actually close the entire bracket, you put the square on the outside, right? You can see this? Okay.
Yes.
And then you say equal. There it is. Not comma. Now we must round off. Let's just go ahead and round off to 1 decimal place. What does rounding off to 1 decimal place? What is the answer going to be if we round this off to 1 decimal place?
0,6.
0,6. Hundreds. because the 2 says to the 6, we must stay the same. Things must not change. Okay. Debucho M, you're saying you are lost where the exponent is concerned. Haibo. Am I not talking to the guy who got 100%, who got everything right for trigonometry in the previous term? Okay, just Katlejo, sorry, I just want to repeat this for Debucho in the comment section. He's saying he's lost. Cos squared of 37,6. I am saying that in order to be able to evaluate this, you must write cos of the angle, and then we take the exponent, whatever it is, we write it external to the entire trig ratio. We must first evaluate cos of the angle, then the exponent must be applied after the evaluation of the trig ratio with the given angle. This is always the case whenever you have an exponent for your trigonometric ratio. Okay, that is the safest way to be able to then get our answer. Okay, so please, all the time, guys, whenever you have an exponent, make sure that you first attach the trig ratio with the angle. You put the exponent external to the entire trig ratio with its angle, then you apply the exponent afterwards. So this is basically how it would look like in your calculator. Cos of 37,6, you can see that 37,6 is in its smaller nyana bracket alone, and then you are putting a bigger nyana bracket so that you square whatever you got for cos of 37,6, which gives you 0.6 if you round it off to 1 decimal place. Okay, I think I think we are now fine, and I think even Katlejo is like saying, I said this thing is too easy, man, too easy, right?
Mm-hmm. Yeah, it is.
Yeah, too easy. So seeing as though it's too easy, I'm going to move on to the next thing that you need to be able to know how to do when it comes to your trigonometric application. So solve for theta. Let's come here. Did you do trigonometric equations, my good and beautiful friend Katlejo? Did you do trigonometric equations?
Trigonometric equations?
Yeah.
No.
At school? Okay. You see, today I'm okay. Let's change this to round off to 2 decimal places. Okay. We'll get back to that. Okay, don't worry. The cosec second chord. Let's just, for now, let's try and drum in the basic trig ratios. Okay, so here is a question here. We are asked to solve for theta. We need to find the angle here, okay, which we can place here. Cos of that angle should give us 0.5. So the way we do these questions is we do the following. First and foremost, we are given the trig ratio cos of theta, which is equal to 0.5. So what we must do is the trig ratio must be isolated on the left. So when we are here, we are in a very good place. There's a numerical value on the right. Okay, so we have a isolated trig ratio with an angle. So this is the isolated trig ratio with an angle, and then on the right hand side we have a numerical value, in other words a number. Okay, it's just a decimal number. Okay, so when we are here, we are in a good place. What we then do whenever there's an isolated trig ratio with an angle with a numerical value on the right, we simply do the following. We say theta is equal to arc cos of 0.5. This only happens when the trig ratio is isolated with the unknown angle. We take the inverse of cos on the right, then evaluate the angle using the inverse of cos. That should give us the angle theta after we have done so. So now you're going to ask yourself the question, but say, how so? How do we do that? How do we evaluate the inverse? Okay, because this here is cos theta. Now all of a sudden, when we take cos on the right hand side, we take the inverse of cos, or in other words, we usually refer to this as arc of cos. And simply put, guys, if you go to your calculator, do you see these, the inverse of sine, the inverse of cos, the inverse of tan in yellow? Do you see that? 1, 2, 3, all of these in yellow. Do you see these? Katla?
Yes, I see them.
Yeah.
By shift first. Then
Yes, very
with the
good.
negative one.
Amen. So we're going to press shift first. Okay, and then we are going to press, we want cos specifically, the inverse, so we're going to press cos there. And voila. Now, the cursor key is just ready for us to actually put in the numerical value, which is what? 0.5. Close the bracket. Then we press equal. Oh, so theta is equal to 60.
60.
You know what's beautiful now is that you can go and check this thing. If we say cos and we substitute 60 in the place of theta, look at this. Cos of 60 gives you what?
1/2.
Which is?
With 0.5.
Yeah, so it works. Do you see? So theta is really equal to 60 degrees. So that's example 1 for you. Are we okay? Example 1 fine?
Yes.
Yeah. So they say solve for theta, and usually in grade 10, they say the theta angle is acute. Do you still remember what an acute angle is? Katleho? An acute angle. It is.
I don't remember.
Eh?
I don't remember.
Okay, what do you think? Let's start there. What do you think an acute angle is? Do you think it's that cute? It's that cute guy. It's that angle.
Yes.
Ish. I like that ish. So an acute angle is an angle between 0 and 90 degrees. It's an angle that is less than 90 degrees. Right? So you see the theta angle, it's 60 degrees. Isn't this an angle between 0 and 90?
Between 0 and 91.
Do you see? Okay, let's move on. Let's do another one. Another example. So remember, what did I say we need to first do whenever we are given a question like this? We need to isolate the trig ratio on the left. Is the trig ratio isolated? Or is there something interfering with the isolation of the trig ratio? Trigonometry, is the trig ratio isolated?
No.
No. Who is interfering?
Yes.
Who's interfering on the left-hand side so that the trig ratio gets isolated? Who's there that's interfering?
I don't know.
Okay, it's the 2.
Maybe I'm just scared. I don't know.
Don't be scared, Lindra. So the 2 here is interfering because the trig ratio is not isolated because there's the 2. The 2 and the sine theta have a relationship. They are multiplied to each other. So how do we then get rid of this 2? We use the inverse, which means we need to do what? To get rid of the 2, we must divide by 2. But what we do on the left, we must do where? On the right. So then that leaves us with sine theta. And you can grab your calculator and say 1,124 divided by 2 gives you 0,562. 0,562. Now the trig ratio has been isolated. You see? Now we can go ahead, because the trig ratio is now isolated, we can go ahead and take the what? The inverse. You see? Because the trig ratio is isolated, now we can do this. 0,562. Let's use the calculator and figure out what we get. This is grade 10. So now you can say shift of sine. There it is. There it is. Ooh. Okay. Then we can say 0,562. Close the bracket and say equal. There it is.
192.
Exactly. And we needed to round off to how many decimal places in this case? 2 decimal places. So 2 decimal places means what? 192. We put our line, we look at the 4. What does the 4 say to the 9? It means we are going to have what as the answer? I'm listening. Answer?
The 9 is not changing.
Okay, the number is not changing. So then theta is equal to 34,19 degrees. Are we together so far, Miss the Katlejo? Are we good? Are we okay? Surviving?
Yes.
All right. I'm gonna look at one last example under this thing. Actually, maybe 2. Sine 2 theta is equal to 0,435. Sine 2 theta is equal to 0,435. Is the trig ratio isolated? Yes, it is. Very good. The trig ratio is isolated because the coefficient of the sine of the trig ratio is 1. This here is something we are going to have to keep. All right. We can't start off this question and say, I am going to divide by 2. No, we can't. Okay. So what we are going to do is going to say 2 theta is equal to, we are going to take the inverse of sine 0,435 on the right hand side. Very important. We take the inverse of 0,435 because we don't have a coefficient this time that basically is more than 1 or is not 1, because if there was a coefficient that was not 1, we would actually divide by it first before we took the inverse of sine on the right. But we don't do that. We take the inverse of sine on the right because, okay, because sine, okay, there's no coefficient. Okay, the only time we ever divide like we did in this question is if the coefficient is actually obviously before the trig ratio. Then we divide by that coefficient. In this situation, this is part of the angle. 2 theta is part of the angle. This is what we call a double angle. It's part of the angle. So we can't open up this question and say we are going to divide by 2. That actually makes things extremely wrong. We can't divide by 2 because this is affecting the angle directly. So what we do is we actually take the inverse of sine on the right hand side. We take the inverse of sine because this is our approach whenever we are dealing with trigonometric equations. Okay, we take the inverse of sine on the right hand side. So 2 theta is equal to, let's grab our calculator there and take the inverse of sine. So when we do that, shift inverse of sine, I say 0.435. So what did you get, Katlego?
25,7852.
Exactly, awesome. So you get 25,78529,388. We are not done yet. Then the next step is, you see now the coefficient of the angle. We need to now solve for the angle. So now, guys, we are in the position of doing what? Dividing by 2. This is very important because the coefficient is not for the trig ratio here. The coefficient is for the angle. It's twice the angle. Okay, that's why we need to first start by taking the arc of sine. Okay, arc of sine 0.435. We get that value. And now we can, as we are striving to get the angle theta, we divide by the coefficient of the angle to get that. So we're going to come here, divide that by 2. Voila. Who would have thought? Round off this.
32.
So?
You said 32 there.
Oh, I divided by 32. Look at that. How silly am I, eh? How silly. Thank you so much, eh? You helped me out there. Okay, I wasn't even looking. Okay. Yeah, look at that. Thank you so much, eh? Simos, you are good. Let's just go back a little bit because obviously that was tampered with. Sine inverse of, let's do it again. Inverse of 0.435. That's where we had started. Then here we divide by 2. Okay. See, okay, so this is where we round off because we only round off at the end. It's very important. Okay, you might wonder, why did I decide to actually write all of this down? It's because I know my rounding off needs to happen at the end. So I use the full wrap of that answer that I got after evaluating arc cos of 0.435 as it is in the calculator. I simply just go there and divide by 2. Then I get 12, now I have to round this off to what? To 2 decimal places. 8, 9. What does the 2 say to the 9?
The 9 is not changing.
Exactly. So the answer is 12,89 degrees. So very important, this thing. The fact that we don't divide by 2 because this is the coefficient of the angle. Okay, we first have to, by nature, we need to first by nature evaluate the inverse of sine. Okay, and then after that, because there's 2 theta, we then divide by 2 both sides, and then we get the answer theta is equal to 12,89. Because remember, we're supposed to round off to 2 decimal places. The 2 says nothing to the 9. It says you just stay the same. We don't increase, we stay the same. So that's why the answer is 12,89. Okay, I think I'm going to do one last one with the equations just so that we can have a full house when it comes to trigonometric equations. Okay, 1 plus 2 cos, then there's an angle here, it's x plus 20 degrees, it's a compound angle, equal to 2,356. Okay, 1 plus 2 cos into x plus 10 degrees. Okay, equal to 2,356. So we need to solve for the angle x in this case. All right, we need to find out what that angle is. So question, is the trig ratio isolated? If not, what is preventing its isolation? Okay, so first things first, I'm sure you can see there is 1 plus. This 1 plus, the positive one needs to go. But in order for it to go, what do? We take the 1 over because it's a separate term from 2 cos into x plus 10. The relationship between 2 and the cos is multiply, whereas this here, this 1 is a alone term. Okay, so we need to first take the 1 over, transpose the 1. So this becomes 2,356. If you take the positive 1 over, it becomes minus 1. Now you're left with 2 cos into x plus 10 degrees. This looks good. 2,356. 356. Okay. 2,356 minus 1. That's 1,356. 1,356. I need someone to answer. Debucho is asking, why aren't we adding 1 and 2? Right. This all has to do with the relationship. This 1 is alone. It's separated from 2 into 2 cos x plus 10 degrees by this plus sign. But the relationship between 2 and cos is one of multiplication. Now, if you remember band math, can we, in fact, sorry, if we look at terms, can we add 1 and 2, where 2, of course, is having a trigonometric ratio following itself as a coefficient? Can you add this 1 and 2 together? No ways, guys, you can't do it. Because this 2 is not a single term, all alone. It is 2 cos into x plus 10. It is one single term combined together. So 1 plus 2 cannot be feasible. Why? Because board math says no. Board math says no. You cannot add these two numbers at all. You can't. Because this 2 is multiplied to cos into x plus 10. Okay. So hopefully we are understanding that. Okay, you can't add. Right? That's like someone saying, is it possible to add this 1 and this 2? No ways. Why? Because of board mass. Remember, with board mass, we know that there's a priority of multiplication over addition. So the multiplication needs to happen first before we can add anything to anything. Okay, because of board mass. So in the same vein, this 2 is multiplied to cos into x plus 10. We can't add this 1 and 2 together because 2 is already committed. This is like saying, you can't be married to someone else's partner, because look at this, man. I mean, especially where polygamy is not encouraged. This is someone 2 already is in a committed marriage. This 1 is single. You cannot come now as a single and interfere with this beautiful marriage. No, guys, it's not feasible. Okay. All right, let's continue. Now that we are in this stage, what do we do? Lerato, very true. We then now can divide by 2. Why do we divide by 2? Because this 2 is a coefficient. But remember what we do on the left, we must do on the sweet right. 1,356, we divide that by 2. What do we get on the left? On the right? 0.678. 0.678. Now, what's the next thing? Remember, this is the angle. The trig ratio is actually isolated because it does not have any other coefficient or constant term. So now at this stage, yes, we then take the inverse, 0.678. We grab our calculator, its cos of that particular answer we had previously, it's 47.31. All right, 47.31244701, and then this plus 10, we transpose it so that it becomes minus 10 on the other side, and that leaves us with an answer which I'm sure is 37.3. remember 31, the 2 says what to the 1? We stay the same. Okay, so the answer is going to be 37, 31 degrees. And there we have it. Okay, there we have it. Right, so Katejo, I'm going to hold my stop nonsense of the trigonometry up until here with you today, and other trigonometric situations and problems we will address at another time where the grade 10 syllabus is concerned. So I'm gonna hold it right here. Let me leave you with some homework, or let me not say homework per se. Let me say game challenges. I'm gonna leave you with some game challenges to do, and then the next time when I do the live session, continuing on with the trig where we left off, we'll check the corrections. We'll check your corrections, and then we'll continue from where we left off and pick it up from where we left off in the trig with the equations and do something else. Okay. Okay, but you must hang on, even if you leave the call, but you must hang on and you must take down the problems so that you can do them in your own time, you see. And then we'll check out further things in the next session. Okay, grade 10s do trigonometry, but I guess in some schools grade 9s do trigonometry at the end of the year to prepare the grade, and those grade 9s who are going to be doing pure maths in the next year. So some schools may do that. It's like enrichment, sort of like helping those learners to be in a position in the following year where they can be able to do certain problems, you see. Okay, so here are your game challenges. Let's write them down. I need to at least give you a few so that I can see that you understood what I taught you. It would not be right if I didn't. Oh, okay. That's why, you see, I'm giving people a chance. Okay, hopefully you are appreciating the slow, nice pace that we have taken as we're doing it, so that you guys can take it in slowly but surely. You see, slowly but surely. And that's why I don't want to do everything that has to do with trig. I want to do one portion now. I will obviously save this video, go and post it onto my YouTube channel as well, so that people can have the chance to watch and rewatch it whenever they want. and other grade 10s that maybe missed the session, because I can see some of these grade 10s sleeping in their beds. They are snoring. They are making so many noises in their households right now. And the parents are getting agitated. The brothers and sisters can't sleep because of the snoring noises these kids are making. I can just see them now in my mind's eye. Okay, so I'll post up for them so that they have a chance to also partake of what we partook of this night, you see. Don't want to leave anyone behind crying alone. Okay, I think these are 7 good problems. 7 is a very special number because it is a number that represents completion. Okay, yeah. So I hope this was really helpful. So let me just hover over what. Okay, I'll show you again the game challenges, all of them, so that people can screenshot and then do the problems on their own. No, I did not forget the brackets. I didn't at all. It's very deliberate, this problem. It's the way it is. Okay, yeah. Let's see if people can fly. It's deliberate. Okay, for this one there's a bracket, there's a bracket, but this one that deliberately is no bracket. So oh, actually yes, you have a point there. You have a point. You have a point. It's this one that I wanted. So we'll do 8. So that one has brackets, but this one, yeah, that's fine. Okay, yeah. Yo. Okay, are we good? Screenshotted. We're gonna do them so that we can make sure that we are fine. We are going to make sure we round off. Let's say round off to, let's say, 3 decimal places, just to change it up here, and to also test if our rounding off skills are good. Okay, yeah, all right. So what are we doing here? We are solving for theta, where theta is an acute angle. Hopefully Deborah will never forget what an acute angle is. Okay, right. Hopefully that was fine. That was good. Now let's cross over. Carlejo, thank you so much. I hope that was okay. We will pick up obviously more and more in later sessions. Let's see if we can pick up this guy, because this guy has been shame. Lerato has been like, you can see on my back about what is this topic, geometry. I've never seen a person so hungry for geometry. Okay, you're welcome, Sabrina. Sabrina, you remind me of, what is it? There was a cartoon that used to play back in my time called Sabrina. You used to call Sabrina the Teenage Witch. Hopefully you don't. But I'm not saying you are, so I'm just saying that. So I will let my good friend Katleho go. Thank you so much. You can be there in the comment section. Lerato.
Yes, sir.
Yo. You've been harassing me, you. Ay.
Sir, I need to pick up my game. Term 1 was not my time.
I need to pick up my game.
And it's been days when I was asking for this topic.
It's been days. Yeah, you are a harasser. You have never seen someone harass me so much. But I mean it in the greatest amount of love. I can actually summon from the heart. So let's take it one step at a time. Hey, let's take it one step at a time. It seems like I can see you are not sleepy at all. Like you are so fresh. It's almost as if like you are going to go for a marathon run. Hey, let's do this topic of yours. Geometry. Hi. What should I do? Maybe I should stop this live and restart it, or maybe I should just combine it, because I just think it's gonna be a very big video, this one. It's gonna have trigonometry and geometry. I'll just call it the paper 2 buffet or something like that. Hey, so you still remember all of your all theorems and axioms and the theorems, axioms, definitions that were done in grade 9? Because
Yes.
those ones are very key. So let's start here. You are going to tell me, and I'm just going to draw when you are going to speak. Let's see how amazing you are. There we have it. Tell me the relationship between B1 and B2. Hopefully all of us know, that this year AC, all right, and B, let's say that this is B, okay, and then that arrow, we call this a ray, R-A-Y, we call this a ray, okay, and this is a point, all right, this is a line, this is an angle that is formed, okay, and this is another angle that is formed. Angles are measured in degrees, by the way. They are measured in degrees. From this line to the ray, there's an angle, and this angle is a certain degree. Then from this ray to this line, there's another angle. So there's a relationship that exists between those two angles.
It says B1 plus B2 equals to 180 degrees, angles on a straight line.
Oh, look at this one. B1 plus B2 is equal to
180 degrees. Angles on a straight line.
Angles on a straight line. Oh, look at that. So there's this document that teachers, they usually expose their learners to. It's called the Acceptable Reasons document. When you're in grade 10, 11, and 12, you get exposed to such angles on a straight line. So basically this theorem, what it says if a ray is drawn from a point on a line, then the sum of the adjacent angles, and this is the key word, adjacent angles, is 180 degrees. Okay, so this is like the full theorem. If a ray is drawn from a point, there's the point, on a line, this is the line, then the sum means the total, the sum of the adjacent angles. So B1 and B2 qualify as what we call adjacent angles. These are angles that are next to each other. Angle B1 and angle B2. The word adjacent means next to each other. So the sum of the adjacent angles is 180 degrees when that is the situation. Thank you so much. And our good friend Lerato has summarized it for us. Algebraically, this is like saying angle B1 plus angle B2. We put the little caps on top of the B1 and B2 to denote that these are angles equal to 180 degrees. And then our reason, whenever we give a geometrical statement pertaining to a certain proof or theorem, we always give the reason in brackets. And this is the short form of the reason, as acceptable as the reason gets. Okay. You've got it, eh? Thank you. Next one, which is like, we say this is the, the converse of the theorem. This is the line. Let's say this is another ray here. We have B, we have X and Y, we have A, B, and C. Now, if we discover that in actual fact, X plus Y is equal to 180 degrees, what does that then mean? It means that ABC is a what?
Mandiasi, yeah. It's a straight line. Oh.
Yeah. Okay. Yeah. I usually play this trick with my learners at school, and I usually do this to them. And then I usually ask this question to them. Is AB a straight line? I usually ask them that. And then, do you know what my learners usually answer when I ask them that question?
Nope.
Nope. And you would have answered the same thing, Moslerado, right?
I would have said AB is a straight line.
Why?
Because E1 and E2 is equals to 180.
Okay, wait. You are saying what? Can you repeat that?
Oh, it's C. C1 plus C2 is equals to 180.
Okay, Lerado, I don't see, there's no C1, there's no 1, and there's no 2 on my diagram. So what are you talking about?
Yo, how will I answer this? Mara, when the angle on C, those two angles, is equals to 180.
Yeah, you are right. But how would you identify those angles as if you don't have the 1 and the 2?
Yeah, that's a tough question.
Okay, so remember that there is a conventional way of naming angles when you don't have, okay, I like what Sabrina is saying there in the comment section. The 130 degrees, you can say ACD. Remember, ACD. So this here, right? Please, or you can say it's DCA. Are you with me?
Yes.
Yeah, that's another way of identifying the angles. Or some people say angle ACD. Remember, the middle letter still denotes the angle. Angle ACD, that middle letter, you see? Or you can say angle DCA. Are you with me? So that's very important to know how to be able to identify an angle. The conventional way of being able to name an angle using the 3 letters, the middle letter denoting the actual angle. Very important. Okay. So like you said, Lerado, I agree with you fully. ACB is a straight line. Why? Because the adjacent angles, when you add them together, they give you 180 degrees. And this is the thing about the theorem here. It says if the sum of 2 adjacent angles is 180 degrees, then the outer, you can say legs or arms, because usually they use these interchangeably, the outer arms form a straight line. Okay, so yes, the question is ACB a straight line? Yes, it is. Okay, you are seeing wavy things like, this, when you look at the diagram itself, you're like, according to the visual, it doesn't look like. But you see, the thing is that 2 adjacent angles, they add up to 180 degrees as per the theorem. If the sum of 2 adjacent angles is 180 degrees, then the outer legs or arms form a straight line. So don't be fooled by what you see visually. The angles themselves that are next to each other support the idea that this is a straight line. So that's just something to note. So that is we call this the converse of the theorem, this theorem of the first one. Okay.
Yes.
So this is how we prove. Okay, so you could say we use this one to prove that a line is a straight line. Okay, we actually use that. Okay, let's look at the third thing with regards to lines and angles. I'm sure you know this one. When you sing this one,
vertical opposite angles.
All right, let's see if you know which angles we are talking about when we say vertically opposite. So which ones here are you saying are vertically opposite, and what is the relationship between angles that are vertically opposite? We say vertically opposite angles are what?
Equal.
Okay, which ones? Tell me.
It is a O, ne?
Yes.
Angle O2 is vertical opposite to angle O3.
Okay. All right, very true. And the other
angle O4 is vertical opposite to angle O1.
Okay, all right. So we would say vert op angles. Vert op angles. So you are 100% spot on there. I don't have any argument about that. Okay.
Yes.
So the theorem says if two lines intersect, the word intersect means if there's two lines, they cross each other. These two lines must definitely be as straight lines, right? If two lines intersect, then the vertically opposite angles are what? Are equal. Okay. All right. I think we are going very nicely. Very, very nicely. There's a relationship that exists between these four angles, all of them.
I remember some time my teacher once said it was 360. Not sure.
Your teacher once said. Okay. I like that you kind of vaguely remember, right? Hopefully now you'll move from a place of vaguely remembering and saying that your teacher said to a place of Lerato knows. It is. Okay. So angle O1 plus angle O2 plus angle O3, like you said, plus angle O4 is equal to
360.
Yeah. Okay. And what is the reason that we use there when we say that?
Oh, I forgot the thing.
You forgot the thing. You better remember the thing. There are two things according to the acceptable reason document that you guys are given in grade 10, 11, and 12. It's angles around a point. Yeah.
Yes.
There's a point there. There are angles around that point. Are you with me?
Yes.
Or the other reason is angles in a. The REV is this word revolution. Okay, right. So guys, yes. We are just doing grade 10, but recapping on the grade 9, because grade 10 Euclidean geometry requires us to recap on earlier definitions, axioms, and theorems that we covered in grade 8 and 9. If those are not solid, guys, you might as well say Teletubby goodbye to Euclidean geometry grade 10. because we need to have those very, very, very well sorted. Okay. The next one has to do with what? These lines.
Parallel lines.
Yeah. So there are three relationships between angles that we find between parallel. Three relationships between parallel lines.
Is it the corresponding, co-interior, and the alternative?
You should be made the president of Euclidean Geometry. What do you think?
I just remember the things.
Yeah, I can see you remember everything. That's for sure. Okay. So there we have it. We have the F relationship.
The corresponding angles.
You see the corresponding angles. Okay. Now I'm just gonna formalize it just a slight tad bit so that we can have some formality in this one. And this theorem, it says if two lines, all right, if two lines are cut by a transversal line, so that the pairs if two lines are cut by a transversal line, so I see what's happening here. So if two lines are cut by a transversal line, then, see now I'm writing, right? Then so if two lines are cut by a transversal, if two parallel lines are cut by a transversal line, then the angles that are corresponding are equal. Okay, and I usually call this simply this. Okay, so this line would be referred to our transversal line. So this would be like your transversal line, and then these two lines would be parallel. So I usually say it's on top. These two are corresponding.
Nope.
On top, corresponding. These two angles are equal.
No.
Why are you saying no?
Oh, it's not supposed to be like that. I thought it was the inside.
Corresponding. I think you're thinking about co-interior. You corresponding. Remember, corresponding is your F shape. Okay.
Like the F, the inside of like the first step, then under the
and then
line.
underneath.
Yeah.
So that's why I'm saying it's on top, we are equal. Bottom, we are equal.
Oh, it's like, oh, okay, now I see it.
Yes, okay. Because remember, if you turn this upside down like this, okay,
still an F.
Still an F. Okay, so like I said, it's on top, bottom. I usually say that to my learners, that they can remember corresponding angles bottom, bottom. So on the bottom of this parallel line, there's an angle on this side of the transversal line. The bottom of this parallel line, these two angles are corresponding. Same position on two different lines that are parallel. Bottom, bottom, we are equal. Top, top, we are equal. Are you with me? So that's why I usually actually say that to my learners, and they are able to remember it quite easily. Top, top, bottom, bottom. Okay? But it needs to be on the same side of this line, which we call the transversal line. It can't be top, top on different sides of the transversal line. It has to be on the same side. So on the right, top, top, bottom, bottom. If this parallel line extended further, on this side, the left, it would be top, top as well, and then bottom, bottom. That's also equal. Are you with me?
Yes.
Yeah, so I hope that makes sense, and that's basically corresponding angle, the F shape. Okay, so F shape is corresponding. We know that those angles are equal. The second relationship is your N shape, or we usually call it the Z shape.
Z shape, alternative.
Yes, exactly. Okay. So if this line is parallel, these two lines are parallel, we can see where that is. This line is parallel, we can see where that is. So those are the angles that are equal. Angles that are equal. Angles that are equal. Parallel lines. Are you with me? Okay.
Yes.
Yeah. So it's on condition that the lines are parallel. If the lines are parallel and there's a transversal line that cuts through those parallel lines, then we say that the alternative angles are equal. And the position of the alternative angles, we can see where those are. Right?
Yes.
Yeah, whether the N is like this, or the N is horizontally placed, or the N is sort of like a funny one, you know. Yeah, Z or N if you want. So yes, alternate angles or alternative angles. Okay. Then the third relationship. Okay, so alternative angles are also equal. Corresponding angles are also equal. But co-interior angles
equals to 180.
Co-interior angles, they have a sum of 180 degrees, as you have said. And this is the U-shaped relationship. U, okay? Or sometimes they say C. This is like the armpits. If you have your armpits, your stinky armpits, this is basically what you would refer the angles at the armpits. They are the angles that add up to 180 degrees. Yeah. Okay. Okay. So I think those visual diagrams are sufficient. I'm not going to really write down statements and all of that stuff, but I think we get the idea. There's the F shape. On top equal, bottom equal. There's the Z shape. We can see where the positions are, the alternative angles. Those are also equal. And then lastly, co-interior angles. Those angles, as long as there's parallel line, those angles, the sum of those angles is giving us 180 degrees.
They can also use a maths is fun so they can remember the angles.
That's why I was saying we should just make you the queen of like Euclidean geometry. What do you think?
Nah, don't do that.
No, you don't do that. Oh, okay. That's a pity, man. We would have definitely like carved out your crown of royalty and placed you on the throne right now. I'm sure your loyal servants would be happy to actually oblige as well. Hail to Queen Lerato. Okay, anyways, so the F, the U, the N. That's very true. I like that. Bottom, top, we are equal. You can see I wrote different things here just to show that here we have the sum of the two, so that the angles are equal. The sum should give us 180 degrees. Then of course this one, for alternate angles, we know that they are equal. So when we write the reasons, very important, we write core angles. And then what's important, you always need to state, let's say the lines are A, B, and C, D. We always need to also state the lines that are parallel. Yeah, we don't just write corresponding angles and we say that's it. No, we write the corresponding angles, because remember the condition says if the lines are parallel and there's a transversal line that cuts through those parallel lines, then the corresponding angles are equal. This one says as well, if we write it down, we write co-int angles for short, co-interior angles for short, and then we must also state the given lines that are parallel. Okay, whenever we use that statement of co-interior angles, we must state the lines that are parallel. For alternate angles too, okay, we write alt angles, and if the lines are parallel, obviously we need to then state the lines that are parallel. So very important, 1, 2, 3, we always need to state the reason as well as state the lines that are parallel. That's full reasoning. If there's no parallel lines, our reasoning is incomplete. And yeah, something to note there. Lerato, I don't know if there's anything else. Actually, Queen Lerato, is there anything else that we are missing out there? Queen of Euclidean Geometry.
No, there's nothing I'm missing.
Okay, now
get to the questions.
You get to the questions. Just before we get there, I just want to do the last thing. Triangles.
Oh,
hey, triangles.
Yeah.
Yo, this one. We need to know this one too. So for triangles, Lerato.
Let's see.
We have triangle ABC.
Angle A plus angle B plus angle C is equals to 180. Sum of angles in a triangle.
Sum of angles in a triangle. Okay. Okay. Some people can say that. Some people can say this.
Yeah.
So there's like 3 reasons of choice that you can use. You can say sum of angles in triangle, you can say angle sum in triangle, or you can say interior angles of triangle. Any one of these 3 is fine as a reason for supporting you saying angle A plus angle B plus angle C is 180 degrees. Okay, that's one. The other one, has to do with the exterior. What's important here is that the exterior looks a certain way. The exterior angle is an angle that is formed by the line of the side of the triangle. Exterior angle, okay, is formed by the line of a side, of a triangle in the same plane. Very important, in the same plane. So for instance, if you look at BC, the continuation of BC forms the angle C1. That's why we call this a true exterior angle. So what do we know about that true exterior angle? It means angle C1 is equal to what, my good
Angle A plus angle B.
Thank you. Angle A plus angle B. And then the reason we use for exterior angles.
I forgot. It was exterior angle of something. I forgot that reason.
Here it is.
Triangle. Oh, okay. Yes, I wrote it right.
Yeah, you're 100% then. But this here, look at this triangle A, B, C, D, 1. Is this the exterior angle we are talking about?
Talking about C1, yes.
No.
Which one, Kase? I don't understand.
C1, can we say here in this diagram, C1 is equal to angle A plus angle B? Can we say that?
Let me see. Oh, not sure now, but I feel like it is yes, because it's next to the.
Okay, just check what I said here. I said when I was explaining, I said the exterior angle is formed by the line of the side of a triangle in the same plane. I was very deliberate about that. You see BC continuing, extending. BC is this line. Let's say it's CD. Okay. So it's in the same line. That's why we call it that C1 is an exterior angle. So we can appropriately say angle C1 is equal to A plus B. Here, BC is going in this here. Look at this now. This is at an
it
angle.
kept.
Yeah.
Okay.
Yeah. So that's the important point, because so many people, they take this for granted and they say angle C1 is equal to angle A plus angle B. But it's not here, because angle C1 is not the correct exterior angle, because it's not formed by the side, by the line that's from the side of the triangle. Okay. So must be very careful when we look at our diagram. Otherwise, we will cry. Lerad. And then you'll be asking, where is the love? There will be none. And then you'll ask, where is the marks? And there will be none. Are we good?
Yes.
Okay. What about this one, Lerad?
And this triangle always keep dated. Yeah. I think so. It's AB is equals to AC. I'm not sure.
Okay, obviously that is given. AB is equal to AC. That's given to us. What can we conclude based on what we are given?
Let's see. And this triangle will
about these angles.
Always keep dated.
What can we conclude about these angles? Angle B and angle C. Yes. Angle B is equal to angle C. What is the reason? Angles opposite equal sides.
That reason. In the exam, it never showed up, to be honest. That's why I don't even pay attention to it.
Okay, listen to me now here, Larado. You better pay attention to this one, because if there's a famous one that they use a lot, grade 10, 11, 12, it's this one. If you don't care about this one, it will take care of you. I'm not gonna lie. So this is an important triangle theorem that, so obviously this is an isosceles triangle. That's what this triangle is called. Okay. But now that we are in grade 10, we need to be very, very specific about, and I'm glad that it's new to some of you, this triangle ABC. when we are given that two sides of the triangle are equal, we can conclude if two sides of a triangle are equal, then the angles opposite those sides are also equal. Okay, so that's why we say angle B is equal to angle C. What's our reason? Angles, these two angles are opposite. They are both opposite what? Equal sides. Very critical reasoning, this one. You must not know it. You must know it very well. Angles opposite equal sides. Okay. Here we go again.
Those triangles, man. In grade 9, we only focused on two triangles. That's why.
Yeah, no, that's fine. Now I'm extending your knowledge. I'm extending it, and this extension is very important. Anyways, you see, my learners at my school, because I was teaching grade 9s last year, my learners know these ones. They know them because I exposed them, so they know. So it will be very nice for me to continue on with what they already know. So it won't be like they're seeing this for the first time in their life. But anyways, let's move on. This is also an isosceles triangle. Okay. I mean, it is obviously because you can see that these two angles. Okay.
Isosceles.
Yes, because these two angles, right, they are equal, right? And then this one, because it has one strand, it means that it is not equal to these two. So when that is the case, when we are given two angles of a triangle being equal, what can we conclude? We can conclude the following. AB is equal to AC. Okay. So this time around, it's the angles that are equal. So now, because we are given those angles being equal, we can conclude that the sides are equal. What's the reason? Sides opposite equal. Okay, I see that there's a bit of intermission there, but anyways, yes. So guys, yes, we can conclude that because these two angles are equal, therefore AB is equal to AC. What's the reason? Sides opposite equal angles. Very crucial. Those Here's another one. What type of triangle do we refer to this as? I hope you guys know what type of triangle we refer to this as. What sort of triangle is this? This is called I'm sure you guys know what this is. Yes, Lerato, it's an equilateral triangle. Okay, very good, Sabrina, thank you. Okay, it's an equilateral triangle. Very true. What do we know about the angles of an equilateral triangle? What could you say, something that you don't see in the diagram that you could state? We are given the sides. So if we're given the sides, it means we need to say something about the angles. What can you say about angle A, angle B, and angle C? Angle A is equal to angle B, which is equal to angle C. And what are they all respectively equal to independently, individually? Yes, the angles are equal, but what are they actually equal to individually? Yes, Lerado. Each individual angle is equal to 60 degrees. And guys, there's no formal reason here that I've ever seen, so we can actually say equilateral triangle. You can say angles of an equilateral triangle. Okay. Equilateral triangle. Okay. So that's very, very important. Okay. So we're just going to go back again. What did we learn in triangles? We learned that the sum of the angles of a triangle is 180 degrees. We learned that the exterior angle, remember, it has to be that angle that is in line with the side of the triangle in the same plane. Very important. It has to be in line with the side of the triangle, that exterior angle. What did we learn? We learned that that exterior angle is equal to the sum of the two interior opposite angles. So C1 is equal to angle A and angle B. So the other two angles that are not inclusive of the angle next door to the angle C, obviously in this case. So it has to be angle C1 is equal to angle A and angle B. Okay, so please check the position of these angles, where C1 is situated and which two angles become the same, those angles that are equal. So it's like if you were to move in the direction from those two angles, in the direction you are moving towards C, and outside you have the exterior angle. So the exterior angle is equal to the sum of the two interior opposite angles. Isosceles triangle, if you are given the two sides, then you look at the angles that are opposite to those two sides, and we say that angle B is equal to angle C. The reason is angles opposite equal sides. If we look at in this situation, the isosceles triangle, where we have the angles being equal, then we can conclude about the sides, right? And we can say AB is equal to AC, and the reason is sides opposite equal angles. Then last but not least, equilateral triangle. If we have an equilateral triangle, we are given all three sides are equal, then we can conclude about the individual angles. And we can say angle A is equal to angle B, which is equal to angle C, which is respectively equal to 60 degrees. And the reason is equilateral triangle. Okay. So yeah, that is basically what we now have for triangles. And remember guys, there's a little bit more than this, but I think for today I am going to hold it right there when it comes to the tools that we need for Euclidean geometry in grade 10. Maybe we can look at a few problems so that we can actually like check if we've gotten our theory down. So we can look at just a few problems, just by way of revision. Just a few. Find the values of the letters, give reasons. Okay. So our first one, okay, because we are
I need to find my tools. Whoa.
So we can work this one out, guys, and then yeah, please, we need to find the value of the letters, the small letters, giving reasons. The small letters, obviously, in this case, let's say X, Y, and Z, because we're gonna use X, Y, and Z. for the small letters. So this angle is 30 degrees, we are given. This angle, this here is x. So we are supposed to find the value of x, giving appropriate reasons. Remember, if you find the value, you must also give an appropriate reason. Okay.
DP to 180.
Okay, I see that what you've written down, Sabrina. What's the reason for you saying that, Sabrina, in the comment section? Okay, I see that, Sabrina. Thank you.
From the eraser. So are we gonna answer them after everything we have written, or we should answer them now?
No, you can go ahead and answer them now. Okay, I think for today I'll just leave us with these.
I can't see the second diagram clearly.
Okay, the second diagram just has 38 degrees and there's an x. Okay, I just pointed there to tell that that is the point P.
Okay.
Yeah. Okay, so here we need x, here we need x. We also want to find the value of x here for this diagram. And then I'm just going to do the last one.
Yeah. Hi.
Here we have x and y. Okay, that's 150 degrees there. Okay, so I'm sure we've all established here that x is actually equal to 150 degrees, right?
Yes.
For the first one, yeah. And the reason is angles on a straight line. Okay. Yeah, someone else could have just written the answer and said x is 150 degrees, angles on a straight line. Whereas someone else would have probably said x plus 30 degrees is equal to 180 degrees. They show angles on a straight line, and then they transpose the 30 degrees, and they get x is equal to 150 degrees. Okay, so both approaches are fine. Okay, this is just someone who's decided to show what he's done. X plus 30 is equal to 180 degrees, angles on a straight line. They solve, they get x is 150 degrees, as opposed to someone who just looked at the diagram and knew that because ABC is a straight line, 30 plus what gives you 180, so x is equal to 150, and the reason is angles on a straight line. Okay, so both would be fine.
Can you see the last diagram? We want to draw.
Here it is. Here's the last diagram. PQRS. You have these two lines there, which indicate something. We want x and we want y.
Okay, let me see this.
Oh, and then that one too as well.
Yeah. Opposite. I'm done, sir.
Okay, so lead us along. I think I'm gonna allow you to lead us now. Number 2, what did you get?
X equals to 38.
Okay.
Vertical opposite angles.
Okay, vert op angles. Okay, nice. I agree.
Then here I said x plus x is equals to 150 exterior angles angle of a triangle.
Oh wow. Right. Okay, yes.
And then 2x equals to 150, like
Yeah.
times divide by 2
Yes.
is equals to 75 degrees.
Wow, way to go. Nice. Nice.
Then on the last one, I'm not sure about the reasons, but I think I got it. I said angle Q is equals to angle R equals to 62 degrees.
Wait. You said angle Q?
Is equals to angle R.
Hey, wait a minute. Angle Q. So this angle is equal to this angle.
Yeah. And then I
Why?
said
Why?
angles opposite equals to sides.
Wait a minute. Wait. So this angle and this angle you are saying are equal. My question is, if that is the case, is PQ equal to PR? Because you can only say these two angles are equal if PQ and PR are equal.
Oh, that's why. Nope. Only QR and PR and PR.
QR and
PR.
So
PR.
the angles that are opposite those sides are which one?
P. Yo.
Let's see.
Nah.
Are we together?
Yes.
Yeah. So if this is 62 degrees, if Q is 62 degrees, who is angle Q equal to?
P.
Okay. Now the thing is, the only way you can say that is if you had mentioned in triangle PQR. The only way you can say P alone is if you had said, when you started off your question, in triangle PQR, you are sending me to the specific triangle. So you are looking at triangle PQR. You're right, in triangle PQR, angle Q is equal to 62 degrees, which is also equal to angle P. You can say angle P if you tell me the triangle. But if you don't tell me the triangle, then you must then use the convention that I spoke about. And I said to you, when you're identifying this angle, remember, this here is P. I mean, this entire thing here can be called P. But now, if you want to specify the P you are talking about, if you haven't mentioned the triangle, you must say angle RPQ, or you say angle QPR. Are you with me?
Yes.
Yeah, but if you have this thing here in triangle PQR, then it's okay to say angle P, because you are telling your teacher as he is marking you that you are talking about triangle PQR. He goes to the triangle and then you are saying angle P. Of course, that is angle P. That's the only angle P in this triangle. Are you with me? But if you don't specify, then you have to say QPR is equal to angle Q. Okay. What's the reason that angle Q is
angles opposite equals to sides?
Angles opposite equal sides. Remember, in English, the sides actually accommodates the fact that you are saying two sides, because sides is plural, it's not singular in English, you know.
Okay.
So angles opposite equal sides. Okay. You update your diagram. We have 62.
Then you can use angles in a triangle.
Yeah, there we go. So what do we say? I'm listening.
Angle P plus angle Q plus angle R
plus angle
equals to 180. Angles in a triangle. P is equals to 62 plus 62 plus X equals to 180. 62 plus 62 equals to 124 plus X equals to 180. X is equals to 180 minus 124. X is equals to 56.
Yay, nice. X is equal to 56 degrees. So that means we update that diagram. We've got X is 56 degrees. So for
let me write something for the angle, for angle Y. Triangle PQR is equals to Angle P plus Q
Let me
plus.
know.
It is, there is an S, Moss.
Yes.
Yes. This goes to 180. P. I said in triangle PQR.
Okay.
Ishman, PQS, man, sorry. QPS.
In triangle?
PQS.
Okay, triangle PQS.
Angle P plus angle Q plus angle S is equals to 180 angles in a triangle.
Okay.
And then angle P is equals to 62 plus 62 plus Y equals to 180. Y is equals to 56.
Okay, hang on a little bit. You said in triangle PQS.
Yes.
But remember, this angle P refers to this angle P that is in triangle PQR. So it's just this small portion. There's this part that we can, this one.
Okay, I see what you're
Don't
talking
know
about.
that part. So we don't know it yet. So remember, if we are talking about triangle PQS, we're talking about the big triangle. But
Yes.
P in that angle, we don't know what this part is.
And I know the Y is equals to 56, but I don't know how to prove it, like the reason.
Y is equal to 56. You are sure that Y is equal to 56?
Yeah, I'm sure, but the reason, that's the only reason I don't have.
How are you sure? Why are you so sure that? Okay, someone is saying 56 is alternate to X. No, it's not. Remember, there are no parallel lines here, okay? These are equal sides. QR is equal to RS, which is equal to PR. So there's something else that you're supposed to be seeing. Look at this triangle, PRS. Do you see it?
Yes.
PRS. What is this X value here? What's the relation?
Exterior.
Yeah, for this triangle. What are the two interior opposite angles?
Y.
And?
62.
It's Y. And this angle here, this angle that we don't know. Remember I said that this angle we don't know.
Okay. Oh, okay. Now I see it.
Yeah, that's what I'm talking about. This part that we don't know. But we can tell what it is because we know that PR and RS, they are equal. So if PR and RS are equal, in that triangle, in triangle PRS, this here, S is Y. What about this angle P here, the small angle P? Isn't that equal to Y as well?
It is.
Yeah. So what I'm saying is that in triangle PRS, angle P is equal to angle S, which is equal to Y. The reason? Angles opposite equal sides. Now, that is why we fill in our diagram. What's nice here is that whenever we find something and we find it's correct, we must update our diagram so that we know what we have. So you said this is an exterior, right? But we know it's 56 degrees. These are the two interior opposite angles. So we can use that relationship to find the value of y.
I'm gonna do y plus y is equals to 2y, then you divide by 2.
Y
Then you
plus
get
y is equal to? Y plus y is equal to?
2y.
Y plus y is equal to?
Equals to 56.
Okay, it's equal to 56 degrees. What's the reason?
Exterior and the angle of the triangle.
Okay, you see now we are talking exterior angle of a triangle. Then
2y is equals to 56.
thank you.
Then you divide by 2, then you get 28, like Sabrina said.
Thank you. Thank you, Sabrina, as well in the comment section. Yeah, Sabrina is popping here in the comment section. Thank you. There it is. Y is equal to 28. Okay, wasn't that painful?
It was not that bad.
Not at all, hey? Not at all. Just that there are certain things now that we are waking up to. It's like our sleeping giant of Euclidean geometry is waking up. And we are actually now implementing and applying the tools that we had just spoken about. So that's why it's so important. Euclidean geometry is as easy as how well you can remember all the theorems, all the diagrams, and know how to apply them in a diagram when you look at it. So you see, if I don't know this thing of angles opposite equal sides, do you see just in this problem in and of itself, how many times we use this thing that you guys said, I never did it last year. This I'm learning for the first time. Do you see how much it appeared in this problem alone?
Yes.
Yeah. So do you see how important it is? That's why I said to you, yo, this one, hey, this guy, is dangerous, this one. Okay? And if you don't know him, he will punish you. He will punish you. Right. Furthermore, Lerado, please, this idea of when you are working in a certain space, identify the triangle you are working in so that you can have the liberty of using the letter for that in that triangle without having to say angle PQR or angle PRQ. You can only do this thing of writing letters when you have identified the space you are working in. And do not then confuse. The minute you say P, you think that even in triangle PQR, this same 62 degrees that you call P is the same P for the entire triangle PQS. No, it's not, guys. It's not. It's not.
Yes.
Remember that mistake you nearly made because you wanted to say angle P plus angle Q plus angle S. And you wanted to take this angle 62 degrees as if it represents the entire angle, but it doesn't. So these are things that we need to be aware of. When you have your diagram, study it and make sure that whatever statements are made with regards to the diagram, your diagram is updated. It has the information as you get certain things correct. Update your diagram with the new information so that when you look at it again, you can see, oh, I can move like this from here, right? And these symbols, know what they mean and know how to apply them. Also, you saw most exterior angle is also famous. Exterior angle is famous. Angles opposite equal sides is famous. Sum of angles in a triangle is famous. So you must know these things. You see, exterior angle, so we must know some angles on a straight line, so forth and so forth. So we just need to know everything, the tools. Okay. That's why I'm going to stop right there for today, where our geometry is concerned. Okay, I'm not going to go any further. And maybe I can leave you just with one game challenge, and then you can do that when your own time. Now I'm going to say goodbye to all of you in the platform because it's been a day and a half.
But yeah, we did that last year. I know that equation.
Which equation?
The one you are drawing. I feel like I know it somewhere.
Which one? Which equation? What are you talking about? Why am I lost?
It's the diagram you're writing.
Oh, you did it last year. Good for you. I'm happy for you then if you did it last year.
But mm-mm.
The question is, if you did it last year, do you know it this year? It's a new year. Hopefully, it's not new. It's not new year, new. You've forgotten everything.
Let me take a screenshot here.
Yeah, very good. That's what I need you to do so that I can also leave you in peace.
You're covering the letter. I can't see the letter.
Which letter?
On the second diagram.
Can you see it now?
Yes.
Okay.
Then I need to find
A, B, and C. A, B, and C. Okay. Yeah, Leonardo, it was good. Let's call it a night. Thank you. Call it a morning. Yeah.
Okay. Thanks, sir.
Yeah. Okay, you're welcome. Thank you too, Sabrina. Thanks for joining in. Valuable contribution there in the comment section. Thank you so much. It was really appreciated. Okay. Let's love and leave everyone. Have a good one. We'll see each other again, guys. Yeah. See each other again. Yes, Kiarabilo. I do grade 11 classes. That's for mathematics though, grade 11 pure maths. If you would be so kind, if you are actually like only seeing, I don't know, you can go to my YouTube channel. I've recently posted videos for grade 11s so that's grade 11 functions and Euclidean geometry. So we did the first two theorems for Euclidean geometry and we did some problems. So I have a live lesson that I posted up on my YouTube channel for Euclidean geometry for grade 11s. And then we also started functions. So there's also a video that I posted on functions based on these live sessions that I have here with everyone. So you can check that out. Is there any particular question you have? Seeing as though you're asking me, do I do grade 11 classes? Any particular question you have? Anika, yo. I do live videos. Okay, but yeah, right now I'm going to actually head to bed because yeah, guys, it's been a morning and a half and a day and a half. When specifically? It depends. It really depends. Okay, I'm gonna try and have a few sessions tomorrow. okay, with the grade 11s tomorrow. But I'm not so sure yet about the time, but yeah, I'll be live tomorrow, definitely. Okay, I'll be live tomorrow. Okay, for grade 10 I'll be live, yes. I think grade 10 will do 8:30. Okay, grade 10 live, we'll have it at 8:30, because I'm having a session with someone at 6:30 specifically. Then I think 7:30 to 8:30 we'll have a grade 10 session in the morning, guys, in the morning. So I'm having a session with someone, okay, but it will be live. It's just that it will be one-on-one. I'll be interacting with that particular person. I do one-on-one live interactions where I just have you come up and I address what you specifically want me to address. But obviously that comes with a little bit of pricing there, so I do that with people. Then so tomorrow I'll be doing one of those at 6:30 with someone because they want to do quadrilaterals specifically. Then at 7:30 I'll have a grade 10 live session. Then 8:30 I'll probably have a grade 11 live session. So let's bank on 8:30. Okay. 8:30 I'll have a grade actually no, I can't have a grade 11 live session at 8:30. It'll probably be further along in the day, because at 8:30 I have a grade 8 session that's happening. Okay, so it'll be further along morning. Then we'll try and have a PM session. Maybe I'll have a PM session as well with the grade 11s at 7 p.m. So let's work at 7 p.m. Kiarabile. I know some of you are still on holiday and you use your day time to actually mingle and interact and do all sorts of things. So let's say 7 p.m. Sound good, Kiarabile? Right? Yeah. Okay. Okay, guys, I have to love and leave you. Whew. And the army, grade 10 is in the morning. We'll have a session in the morning, 7:30 in the morning. Okay. Sleep well, table watchers. Bye, guys. Bye.